Day 642 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3640, Trionic Array 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n. A trionic subarray is a contiguous subarray nums of L to R with 0 being less than or equal to L, L being less than R, and R less than N, for which there exists indices L, which is less than P, P is less than Q, and Q is less than R, such that nums of L through nums of P is strictly increasing, nums of P through nums of Q is strictly decreasing, and nums of Q through nums of R is strictly increasing. Return the maximum sum of any trionic subarray in nums. All right, y'all, so that may seem a little bit confusing at first, but let's take a look at these examples so we can make sure that we understand what's going on. So right now we see we want to find trionic subarrays or trionic subarrays that go strictly increasing, strictly decreasing, then strictly increasing. So let's see how they do that. So in example 1, our input nums equals an array of integers 0, -2, -1, -3, 0, 2, and -1. The output is -4. So -4 is the maximum sum of a trionic subarray in nums. So let's see what that trionic subarray is. So it says L will be 1, P will be 2, Q will be 3, and R will be 5. So these are representing indexes, index 1, 2, 3, and 5. So let me just go ahead and bring this over here so I could label them for y'all so we could really see what's going on. So index 1 will be right here. Index 2, excuse me, y'all. Excuse me, y'all. Had to drink some water. Hold on. So this is index 1. Boom. This is index 2. Boom. Well, we might just label all of them. Boom. This is 4. Boom. Or we can just go up to 5. Boom. So this is what we have. So this is index 1. This is index 2, index 3, index 4, and index 5. Right? So that's where we started. This was L. Well, let's label these two. So this will be L. This will be, this will be P. This will be Q. Sorry, y'all. Q. And this will be R. Boom. So now, hopefully this input makes sense, right? So this is what they mean by L equals 1, 2, P, Q, or L equals 1, P equals 2, Q equals 3, and R equals 5. Talking about the indexes, and these are them right here. Boom. So now let's go through this explanation. It says nums L through P, which equals 1 through 2, indexes 1 through 2, which is equal to -2, -1, is strictly increasing. It goes -2 to -1. So first, we're checking this first requirement right here, right? Right here. Yeah, nums L through P is strictly increasing. So this is L and P. It's at indexes 1 and 2, and these are the values. Boom. So -2 and -1 is increasing, right? Because -2 is greater than -1. Or excuse me. Yeah, -2 is less than -1. Sorry. Boom. So it's increasing, but that's not what we want. We want to just pair these together. So when we do our sum, we can include these in our sum, right? So this is strictly increasing, right? It goes from -2 to -1. That's increasing because it's negative numbers. Boom. Then, so P through Q should be strictly decreasing. So P through Q is this right here, 2 and 3. This is -1 to -3. That's decreasing. Let's check the explanation. It says nums of P through Q is equal to nums index 2 and 3, which is -1 and -3, which is strictly decreasing. So once again, -1 to -3, that's decreasing. So let's just go ahead and add these to our count. Boom. So we know what's going on. Boom. So for when we need our sum. Now we're doing that. So that was this requirement right here. Now we're doing this last requirement, Q through R. Now Q is index 3, so that is going to be this right here, and R is index 5. So as you can see, it needs to be Q through R. So the 0, even though it's in the middle, it still follows the requirement of being strictly increasing. -3 is less than 0, and 0 is less than 2. So all of this right here, boom, is Q through R. So let's go through it. It says nums of Q through R, which is index 3 through 5, this index right here, boom, which is -3 through 2, which we just went over right here, boom, is strictly increasing. Then, so the sum, so let's go ahead and bring these down here, boom, let's see, boom, so now let's go ahead and add them together. So I guess when we add them together, we only do this one time, and we only do -3. Sorry, y'all. We're not counting the values for the index twice, right? So we could remove one -3, and we could remove one -1. Boom. So let's see. Boom. Boom. Let's get this cleaned up. Then when we add them together, this should equal 4. So -2 plus -1 plus -3 plus 0 plus 2, which equals 4. Boom. So, sorry, y'all. Let me just put this. Well, this is it. Or excuse me, equals -4. Sorry. Boom. So this is this right here. Let me just put this over here. Boom. -4. Boom. So I hope that makes sense to y'all. But just in case it didn't, let's take a look at example 2. Boom, let me go ahead and clean this up for y'all so we can get into example 2. So in example 2, our input nums equals an array of integers 1, 4, 2, and 7. So let me go ahead and copy and paste this over here again. Boom, output is 14. 14, that means the sum was 14. Let's look at the explanation to see how they did it. So this time L is 0, P is 1, Q is 2, and R equals 3. Once again, these are the indexes. So right here, hold on, y'all. Right here, we will say, so this 1 will be, oh, let's do the indexes first. Boom, 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 boom. Then just say index. Boom, come right here. Then this will be L, P, Q, and R, just like this. Boom. So now let's go through this explanation. It says nums of L through P, which is indexes 0 through 1, which is 1 and 4. That's this 1 and 4 right here. Is strictly increasing 1 through 4. Boom. So we put the 1 and 4 down here. Boom. Then P through Q is going to be, nums of P through Q is going to be indexes 1 and 2, or this 4 and 2. Boom, that's strictly decreasing, right? Because 4, 2, that's decreasing. So we only have to put the 2. We don't have to, because it's a sub-array that we're creating. Sorry, y'all, I didn't explain that in the first example. But it's a sub-array that we're creating. So we're just using these elements that we have here. So we're not duplicating any elements. Since we already have the 4, we could just bring the 2. Boom. Then last one, but certainly not least, nums of Q through R, which is index 2 and 3, is 2 and 7. Boom. So 2 is less than 7, so we could just bring the 7 down here. Boom. Then when we add them all together, sum equals 14. 1 plus 4 is 5, plus 2 is 7, plus 7 is 14. Boom, y'all. So that's how the question works, and I hope that made sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we are going to do is we're going to store the maximum trionic sum, or we need a variable to store the maximum trionic sum that we found so far. So we come right here, declare a variable called max sum. Sorry, y'all, max sum. Set that equal to, it's going to be int dot min. Boom. Then we need to find the index used to scan through the array, so we can declare a variable called for that called I. Just set that equal to 0. Then we need we're going to create a constant for the total number of elements. So we're just going to get the total number of elements. So we're going to say let n equal nums dot count. Boom. Then we're going to iterate through the array while there is room to form decreasing segments. So we're going to say while I is less than n minus 1, we're going to open up the brackets. And we're going to find the end of the initial non-decreasing interval, and this is going to identify the peak before decrease. So we're going to declare a variable called p, set that equal to I, and we're going to say while p is less than n minus 1, comma, nums square bracket p is less than or equal to nums square bracket p plus 1, then we'll come out here, open up the brackets, we'll say p plus equals 1. Boom, then we're going to start from the peak, and we're going to find a full decreasing interval and compute the sum of this middle segment by coming right here underneath, sorry y'all, this should be while. Come underneath this, and we're going to declare a variable called q, set that equal to p, declare a variable called sum2, set that equal to nums square bracket q, sorry y'all, q, boom, and then we're going to come underneath this, and we're going to say while q is less than n minus 1, comma, nums of q, sorry y'all, q is greater than nums square bracket q plus 1, then we're going to come outside of this, open up the brackets, and we're going to say q plus equals, sorry y'all, plus equals 1, come underneath that, we're going to say sum2 plus equals nums square bracket q, boom. Then we're going to move the main pointer forward to the end of the decreasing segment to continue scanning. So we'll come underneath this, we're going to say I equals q, boom. Then we're going to come underneath this and compute the maximum sum of strictly increasing subarray immediately to the left of the peak. So we'll declare a variable called sum1, set that equal to 0, declare another variable called max sum1, set that equal to int dot min, and then we're going to say while q, sorry y'all, or excuse me, not while q, we're going to say while p is greater than 0, sorry y'all, while p is greater than 0, comma, nums square bracket p minus 1 is less than nums square bracket p. Come outside of that, we're going to open up the brackets, and we're going to say p minus equals 1. Come underneath that, say sum1 plus equals nums square bracket p. Come underneath this, we're going to say max sum1 equals the max, open up the parentheses of max sum1, comma, sum1. Boom. We're almost there, y'all, but not done yet. Now we need to compute the maximum sum of a strictly increasing subarray immediately to the right of the valley. So, for that, we're going to come underneath this while. We're going to declare a variable called sum3, set that equal to 0. Then we're going to declare another variable called max sum3, set that equal to int dot min. Then we're going to create or we're going to use a while loop and say while q is less than n minus 1, comma, nums square bracket q is less than nums square bracket q plus 1, come outside of this, open up the bracket, we're going to say q plus equals 1, sorry y'all, that should be 1, come underneath that, sum 3 plus equals nums square bracket q, then we're going to come underneath that, say max sum 3 equals max, open up the parentheses, sum 3 comma max sum 3. Boom. Then if either side does not have a valid increasing interval, then this cannot form a trionic subarray. So we'll come underneath this and we'll say if max sum 1 equals int dot min, vertical line, so or max sum 3 equals int dot min, we're going to open up the brackets and we're going to say continue. Boom. Then we're going to update the global maximum trionic sum by coming underneath this. We're going to say max sum equals max, open up the parentheses, max sum comma max sum 1 plus sum 2 plus max sum 3. Then we just need to return the maximum trionic sum found by coming right here. Oh, sorry, y'all. Hold on, y'all. Something, I forgot to close a bracket somewhere. Let's see what's going on. Is it that last? Maybe it's this last one right here. So we should come right here and we need to return max sum. Boom. Let's see if that did the trick. Hopefully that did. It should have. Let's see. It's accepted, y'all. Look at that. Now let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. All right, y'all. 0 milliseconds, 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.